आता कुठं वेळ आहे तर 8 वाजल्यानं.
Good evening, everyone. Hello. Am I audible?
Hello, ma'am.
Good evening, ma'am.
Hello. Good evening. Okay, so today we are going with week 11. So have you guys gone through the lectures of week 11?
Not yet.
Not yet. Okay. So I'm not getting any responses. Everybody okay? Had your dinner?
Yes, ma'am.
Yeah. Happy Independence Day.
Happy Independence Day.
Okay. Okay then. So shall we start now?
Yes, ma'am.
Okay, fine. Before that, are you guys like, have the scores been updated? Can you just tell me if the scores have been updated? See, they are telling me that Seek portal, it has been updated, but not in the dashboard. So can you just check and tell me if your scores have been updated or not?
Ma'am, scores of what exactly?
Scores of week 9 graded
Week
assignment
9,
1.
yeah, it
Yeah,
has been updated, but ma'am,
okay,
there's a
fine.
mistake in like week 9 GA. I mentioned it to not you, maybe some other instructor.
Mm-hmm.
She said it would get corrected, but it still didn't get corrected.
No, today they told me that they have they have rescored it. So can you just check in your portal, on your portal, Seek portal, whether it has been
Yeah,
updated
ma'am,
or not?
I refreshed it just now. It's still showing 85.
Okay,
Like
what
it should
about others?
show
Are there
100.
are there any changes for others?
1 minute, I'm checking.
Yeah, just check it and tell me.
Ma'am, 85.
Okay, ma'am,
80.
I just noticed something interesting is that it's even though it's showing 85 there,
Hmm,
everything in the GA when I'm opening the grade assignment week 9,
hmm,
everything is showing correct. Like it's
okay.
like full marks. Okay.
Uh-huh.
But interestingly, at the dashboard, it's still showing 85.
No, in the dashboard, it won't be updated. On Monday only it will be updated, but I'm just asking you in the portal if it's correct or not.
Yeah,
If
in
it
the
has
in
been.
the like actual grade assignment 9, when I'm opening it,
Ah,
everything is correct.
then it's fine. Okay. So
Okay.
in on Monday the marks will be updated because today was a holiday, right? So they have the dashboard will be updated on Monday. Okay. Yeah. So just wait till Monday.
Okay, ma'am.
Then if
Yes, ma'am.
then also it has not been updated, just let me know. Okay.
Yes, ma'am.
Okay. Fine.
yes ma'am. Same issue face.
Same issue.
मैं 85 शो हो रहा है, मतलब ऑल करेक्ट है फिर भी।
हाँ ठीक है, तो मंडे को वो अपडेट हो जाएगा। आज छुट्टी था तो वो अपडेट नहीं हो पाएगा, तो मंडे को वो सब अपडेट हो जाएगा। ठीक है, मंडे तक वेट करो। ओके
ओके मैम, ओके।
ओके, सो शैल वी स्टार्ट विद द सेशन नाउ और एनीथिंग
Is this a
एल्स?
summary session?
Yeah, this is just a summary session. We will, like, I will be just briefing out the main thing, then we will be solving the questions. Okay, like we have been doing it before.
मैम
Fine. Yes. Okay, so shall we start now then?
yes
Okay then. So first of all, okay, so have you gone through the lectures of week 11? Like you have a rough idea what is it? Anyone?
No, ma'am.
That's good.
I've only seen the first lecture.
Arey wah. Very good, very good. So I'm just telling you beforehand, I won't be going deep. I'll just go, like I'll just have a brief introduction of the week 11 lectures. Okay? Okay then. So the first thing is we have a Bernoulli trials. Any idea what is a Bernoulli trial?
It is
Either
about
success or
probability
failure.
of success and failure. Yeah.
Yeah. So in Bernoulli trial, we have two things. We have a success and a failure. Okay. So, sorry.
नो मैम सॉरी।
Okay. So Bernoulli trial is a trial in which I have two things. The first thing is I should have a success and I should have a failure. There should be two outcomes of it. Okay. And let's yes.
How can we have success and failure together?
Yeah.
It should
Let's
be.
suppose. Okay. Let's suppose I'm tossing a coin.
Mhm.
Okay. If you toss a coin, I'm asking you what is the probability of getting a head. So my success is if I get a head. So this is my
Oh, okay,
success.
got it.
Okay. And what is my
Good.
failure? Getting a
1 by
tail.
2.
Yeah. Okay.
Got
So
it.
the
Got
in
it.
Bernoulli trial, the first thing is you should have like in the trial or in an experiment, there should be two things. It should be a success and a failure. Then only we say that it's the Bernoulli trial. Okay.
Okay. Yeah.
Okay. Now we in Bernoulli trial, if x is my random variable, I let's suppose if x is a random variable, it takes two values, 1 and 0. So 1 is for the success. Okay. If it is success, I denote it with 1. If it is a failure, I denote it with 0. Okay. So this is a Bernoulli trial. Okay. Okay. So let me ask you, if I'm randomly, let's suppose if I'm randomly choosing their person and I'm asking their age, is it a Bernoulli trial or not?
It's not a Bernoulli trial.
It's not a Bernoulli trial because we don't have any two outcomes. Okay. Now we have a Bernoulli trial. Now for this, what is my expectation? Expectation will be what? Okay. So how
Probability
do
of x.
sorry?
Probability of x is equal to 1.
Okay. How do you calculate an expectation? It is, can you give me the formula?
Summation
X into probability of
x equals to x.
Okay. Now, I am making a table here. Okay. Now, in a Bernoulli trial, what are the values that X is taking?
0 and
0 and 1. Okay. Now I'm saying that if my x is equal to 1, the probability is p. Okay. And if my x is 0, my probability is 1 minus p. This thing is clear?
Yeah.
Okay. Okay, now. So I need to calculate the expectation of this. Now, what will be this? It will be 0 into 1 minus p plus 1 into p. Correct?
Yes.
Yeah. Okay. Now, this will be equal to what? P. So now, for a Bernoulli trial, my expectation is equals to P. Okay. Similarly, we can calculate the variance. Okay. So what is the formula of variance? Variance will be, can you tell me the formula of variance?
P times
Expectation of
Expectation
x square minus
into
e square.
expectation of whole square.
Expectation of x whole square. Okay, this is my formula. So when you calculate the value of expectation of x square and calculate the value of expectation of x whole square, if you calculate this, your variance will be coming out to be p into q, or you can say p into 1 minus p. Is this thing clear?
yes, ma'am.
This is fine, correct?
Why there is an expectation of square invariance?
Sorry.
Why there is no expectation of x square invariance? We're just
This is,
calculating variance for x.
this is the formula of variance.
Okay.
What is
Yeah.
Q, man?
Q is the probability of failure. So if P is my probability of success, so 1 minus P is basically what we denote it as Q. Okay.
Okay.
So Bernoulli trial is clear.
Yes, ma'am.
Okay. Now comes the binomial distribution, or you can say binomial random variable. So what is a binomial distribution? Binomial distribution, okay. It is same as Bernoulli, but here we have n independent trials. Okay. So if we have n independent Bernoulli trials, okay, with the probability of success P, okay, then we call it as a binomial experiment. Okay, so the main important thing, whether if we have to see whether an experiment is a binomial or not, there are few things. So the first thing is there should be n trials. In the sense, there should be like n fixed trials should be there. Then second, it should be independent. All the trials should be independent and identical. Okay, right? Independent and identical, and we should have a probability of success. If these three things we have, then we call it as a binomial experiment. Is it fine?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
Yes? Okay. Now, for a binomial, we have a PMF, probability mass function. So for binomial, the PMF is denoted as NCX p raised to the power x 1 minus p raised to the power n minus x. Okay, so n is the total number of trials. X is, let's suppose if my x is a random variable, which is denoting the number of success in n trials. Okay, that is my x. So if I have to calculate the probability that of x, it will be NCX p raised to the power x 1 minus p raised to the power n minus x. This is the PMF of a binomial random variable. Is it fine?
What is PMF?
Probability mass function.
Okay.
Okay.
Could I request,
Then we have the
Sorry to interrupt.
expect. Sorry.
The previous topic, the binomial thing, could you just give a recap? Yeah,
You want to give me the recap?
yeah, please. Sorry for that. I just joined. I'm sorry.
Oh, okay. Fine.
Yeah.
Ma'am, there are so many formulas. Is there like a trick to remember all of them?
There is no trick. You have to remember it, of course. There is no trick, but mm,
Is the
okay.
binomial distribution and binomial random variable are same, or it's kind
Yeah,
of
it's
different?
same.
Okay.
It is same only. So, okay. So, like in binomial, what we are doing, we are just calculating the number of success, right? So, P is the probability of success. And X is what? The number of success in N trials. So, in N trials, we have to choose the probability of success. So X is the number of trials, okay? And 1 minus P is the probability of failure. So, how will we remember this? But, I guess I actually explained in the lecture, like, uh, I don't remember.
Function NCX.
I guess she has not gone deep into the explanation of the binomial. It's fine. Huh. So what is a binomial? Okay, I'll just recap it once again. So first of all, we had the Bernoulli in which we have two outcomes, success and failure. Then this is an important thing. Okay. And we denote if my X is a random variable which is taking values 1 and 0. So one is if one it takes one value, it is a success. If it's 0, it takes failure. Okay. And expectation is P and variance is P into Q, or we can say P into 1 minus P. So this is a Bernoulli trial. Now, what is a binomial? Binomial is just if we have n independent Bernoulli trial with a probability of success P, then we say that it's a binomial experiment. Okay. So if we have to know whether that experiment is a binomial, we have to see there are two things. The first thing is we can classify it as a success or failure. Then we have to check whether we have n fixed trial and they are also independent and identical. Then we say that that experiment is a binomial experiment. Is it fine?
Okay.
Okay. And
Okay,
we
ma'am.
have a PMF of binomial experiment, which is NCX p raised to the power x 1 minus p raised to the power n minus x. Okay.
And I have
Yeah.
a very naive question. Like when you're talking about when you're talking about the Bernoulli thing, where you're talking about the the outcome of it. So when we talk about in general, the probability of success is also kind of a what do you call success or failure types. And then when we are talking about this part, like why we actually what is the general difference, and when we are talking about the Bernoulli level of thought here, a regular probability versus this one.
Can you just repeat once again? Yeah.
No, when we talk about the probability in general, we talk about, again, in terms of success or failure, we are talking about. But when we are talking, we're talking deep into the subject. Here, we are talking about the Bernoulli trial and so on. So, what is there a major difference in the basic to this level, or it's my understanding that I'm not getting it correct, the difference here?
You are asking the difference between the Bernoulli and the binomial.
No, I'm talking about in general what we talk about probability versus the Bernoulli trial, because in probability also we are talking about the success and failure. Here also we are talking success and failure. So what is that makes that difference, or it's a subtle difference, or it's a huge difference, that, or is my understanding is not clear here?
So like you are asking me about like we have been calculating the probabilities, right? So
Yes.
what's the difference between the probabilities and the binomial thing, correct?
Yes, you're right.
Okay. See, this
Actually,
is
he's
just
asking the degree in the normal calculating the probability and using the Bernoulli theorem. What is the degree in between these two? Am I right, Sridhar?
Yeah, in a way.
The
Yeah,
degree
I
of
didn't have the right word to put. Thanks for that. Yeah, please go ahead.
okay. So see, these are the conditions. Like we have a different kind of distributions actually. Okay, so we have been like saying we have a discrete random variable and a continuous random variable, correct? So in a discrete case, we have
Yeah.
different types of distributions to calculate the probabilities, or we have some kind of situations so that we like different situations have been put into different distributions so that we can calculate easily about the probabilities and everything. Okay, so if we have a situation in which we have two types of outcomes, we have success and failures, and those and we have n independent trial as well, we put it into a binomial distribution. So if we have a binomial distribution, we know their PMF, we know their expectation, we know their variances. Okay. So simply we can say that if we know the distribution, we know their PMF, we know their expectation variance, so we can calculate easily their average or the variances or something if we need to calculate. So it's just that we are just we can say that we have just broken down the situations into different distributions so that we can calculate easily the values or the things that we need to know. Okay.
Okay, so when my understanding is right, so can I actually say that all these things comes under the general word of probability here, all this distribution, everything? Should I think in the direction?
Probabilities. We can say that. Yeah, somewhat we can say that if you're calculating with probabilities. Yeah.
Okay. Thank
Okay,
you.
but I'm not sure. I'm not saying 100%. I need to search a little bit about it. Then
Okay.
I'll confirm it to you. Okay.
Because this example of coin toss has actually been, we have been almost like from the
In
second week or
probability.
something we have been talking
Huh.
about.
Hmm.
So I was wondering whether what makes that it even when we talk about the same example, but the
Huh.
approaches and these things are entirely getting different. So I was
Okay.
wondering whether
Yeah,
what
I
is it?
know. I get it, but I never thought it like that. So I'll just do some research and I'll just let you know. Okay?
Thank you. Thank you so much.
Okay. Okay then. So where were these? Huh. So this is a binomial thing. We have the PMF and we have the expectations as well. So in Bernoulli trial, we had the expectation as P. Now this, in binomial, what we are doing, we are having n independent Bernoulli trials, right? So my expectation would be n into P. Okay. Similarly, the variance is what? PQ for the Bernoulli. So if we have n independent trials of that, so the variance will be n into P into Q. Is this thing clear?
Ma'am,
Yes.
ma'am, what is the difference between Bernoulli and binomial?
Can you speak louder?
Ma'am, what is the difference between Bernoulli and binomial?
In Bernoulli, we have only one trial. That is, I am holding a one trial. That is, I am tossing a coin. That's it. And with that, I am having two cases, success and a failure. But what is a binomial? Binomial, we have n independent trials. In the sense, I can have 5 trials. I can have 6, 7, 8, like that. Okay. So that's the difference. I would be having n independent Bernoulli trials. Bernoulli trials, that's why we are saying Bernoulli trials. Okay. So the first trial, if I'm tossing a coin one time, I would be, this would be my Bernoulli trial in which I would be having a success, I would be having a failure. Okay. With probability P and 1 minus P. Okay. And the next, similarly, my second toss, my second trial, but that will also be my Bernoulli trial, but it would be independent of the first trial, like that. So that's the difference between the Bernoulli and a binomial. Okay. Is it fine? Hello?
Ma'am,
Yeah.
ma'am, then we want to say that in Bernoulli trial, the probability of success is equal to the probability of failure in half and half only. No 1/3 and 2/3.
No, we can have different probabilities. It's not necessary that we should have 1 by 2 and 1 by 2. It's not necessary. We can have different probabilities as well.
In Bernoulli.
In Bernoulli, yeah.
Ma'am, can we say that in Bernoulli n is equal to 1
Yeah, n is equals to 1.
and in binomial n is
We
usually
have
more than 1?
more than 1.
Ma'am, I just like this doubt is not relevant to the course. Is there like sum of PMF 2 to the power n for binomial distribution?
2 to the power n. No.
Okay.
The sum of probabilities is equals to 1 only.
No, no, ma'am. I'm not asking the probability. I'm asking the PMF, this function which you have written.
That
So
is a
suppose,
different thing. That is a different thing. The thing is, if we have, okay, so do you know the binomial expansion? x plus y raised to
Yeah,
the
yeah.
power n, right? So if my
Yes, ma'am.
value of x and y is 1, if my x is equals to 1 and y is equals to 1, then I will have 1 plus 1 raised to the power n as 2 raised to the
Yes,
power n.
that will be 2 to the power n.
Ha,
But I
ha.
had a confusion that this can also be 2 to the power n.
This can't be because this will be what? This will be
It
p
is
plus q raised to the power n.
it
If
is
we
equal to
sum
1.
it,
Okay.
okay?
It is equal to 1 actually, because it is p plus 1 minus p raised to power n. Because p raised to power, if we put x equal to pn, y equal to 1 minus p.
So if you just put the value of p here, so it will be what? P plus 1 minus p. Okay, this will be raised to the power n. So p will get cancelled, 1 raised to the power n. So sum of the PMF will also be
Oh,
equal to 1. Okay.
okay, ma'am. Got it, ma'am. Thank
Uh,
you.
uh, yeah. So this was the case of binomial. Okay. So binomial thing is clear. Is it fine? We will be solving the questions. Just I'm asking that binomial, the
Yes,
formula,
ma'am.
expectation, variance, and everything is clear. Correct? Okay. So can you tell me what are the what are the conditions for which I can say that my experience is experiment is a binomial? Just tell me.
There are n trials
Hmm.
and they are independent and identical, and
Identical.
each trial is a Bernoulli trial.
Bernoulli trial. Yeah, that should be my thesis. Then we can say that it is a binomial experiment. Okay. Now we have the third distribution, which is a hypergeometric distribution. Okay. So what is a hypergeometric distribution? In binomial, we had independent trials, right? So if I say if I am uh, let's suppose if I am like I have in a bag, I have balls, okay, of different kinds. So if I'm taking out a ball and I'm like in the second trial, I am taking out another balls, right? So if I'm doing it with replacement, that is, so my second, if I'm drawing out second time, my second draw will not be dependent on the first draw, correct? So that is like in a binomial, they are independent, but in hypergeometric, they are dependent. Okay. That means I will be doing it with replacement.
Excuse me, ma'am.
Right. Huh?
Ma'am, in binomial, it is written that it is identical. Ma'am, what is meant by identical?
Identical means the probabilities are same for all the cases.
Ma'am, for every trial, it is same.
Huh.
Okay, ma'am.
So yeah, so if you toss a coin, okay, let's suppose I'm tossing a coin 3 times. So for the first case, my probability of success will be like 1/2. For the second toss also, my probability of success will be 1/2. For the third case also, my probability of success will be 1/2. So if you see here, all my probabilities are same. They are identical. Okay.
Okay, ma'am.
Okay then. So we have an hypergeometric distribution. What is the hypergeometric distribution? Let's suppose if I'm having um I'm ha n balls. Okay. From this n balls, I am going to select n items without replacement. Okay. And in this n balls, I have 2 items. I have like m number of one item and n minus m of another item. Okay. So from this n balls, I am selecting n items without the replacement. Okay. And let's suppose I am taking x as a random variable, which is the number of items of type 1. Okay. So if I'm selecting this n items, in this n item, I can have x number of items of type 1, that is that is the m number of items, and I can have n minus x, the remaining. Correct? is this condition clear? Okay, let's suppose I'm having like I have 7 balls in a bucket. Okay, in which I have 4 white balls and I have 3 black balls. Fine. Now from this, what I'm going to do, I'm going to take out, let's suppose I'm going to take out like I'm going to draw one black ball. Okay, so I'm going here, I'm taking one black ball. So in this thing, and if I'm going, it's without replacement, I'm not replacing it back. So now if I'm taking out one black ball, so how many balls are remaining? 4 white balls and 2 black balls, correct?
Yes, sir.
Yes, sir.
Yes. Okay, so what is the probability of getting a black ball? It will be 3/7.
Yes.
Okay, now similarly again I'm drawing out a ball. Okay, black ball. Now what is the probability of drawing out black ball? It will be 2/6, correct? Okay.
Yes, sir.
Yeah. So now I will be having 4 white balls and 1 black ball. Yes or no?
Yes,
So
ma'am.
this is the value of x equals to 1. So what is x equals to 1? That means what is the like getting taking out 1 black ball. So this is my probabilities. So this is how. So what is an hypergeometric distribution? Hypergeometric distribution is that distribution in which I am from n items, I am taking out small n items without replacement of m1 type and n minus n of 1 type. Okay. Now, if I need to calculate the value of x, which is the number of items of type 1, I would be calculating it with the formula, which is mx, then n minus m n minus x divided by NCN. Okay, so this is my PMF of hypergeometric distribution. Is it clear? It's a simple thing.
Yes,
Like,
sir.
if I'm asking you, if I have given you that there are 4 white balls and 3 black balls, I need you to calculate the what is the probability of getting a 1 black ball. What you would be doing? It would be like getting a 1. So let's suppose the question is you have 4 white balls and 3 black balls. You have to take out 2 balls. Okay, and what is the probability of getting only 1 ball? So what are the probability? You will be calculating it like 3C1 and the remaining 4C1 divided by 7C2, correct? This is how you would be doing it, right?
Yes, ma'am.
Yeah, it's the same thing. So according to the question, M is what? M is the black balls. Okay. So how many black balls are there? 3. And X is the probability of that is only 1 black ball I should have. So X is 1. Now N minus N. What is N minus N? It is the number of white balls. Okay. So number of white balls is what? N minus M, which is 7 minus 3, which is 4. And N minus X is the number of items of white balls, correct? So this will be 1 only because I have 1 black ball. So in total, I need 2 balls. So the other one will be the white ball. So it is 1 divided by NCN, which is the number of balls, that is 7C2. Got it? Got the formula? It's just a simple thing. Is it fine?
Yes.
Yes or
Yes, ma'am.
no? Yeah, and that's it. So this is the thing. This is the hypergeometric distribution. You just have to remember that, like the condition should be, it should be without replacement. Okay. Is it clear or no?
Ma'am, clear.
Hypergeometric is clear. Everyone? No doubts?
Yes, ma'am.
Okay. Okay, then for this hypergeometric distribution as well, we have the expectation, we have the variance. What is my expectation of a hypergeometric distribution? It is n into m divided by capital N. This is my expectation of a hypergeometric. And variance is what? It will be n m divided by n into n minus m divided by n into n minus n divided by n minus 1. So this is my variance of a hypergeometric distribution. Okay. Normally we don't give this to calculate the variance or not. We will be calculating only the expectations. Okay. Is it fine? Hypergeometric is clear?
Yes, ma'am.
Everyone?
Uh,
Is it
So
confusing?
to arrive at this hypergeometric expectation, so I had to start from the Bernoulli, is it?
Bernoulli?
I mean, when we are talking about, let's say can if the sum is actually, because if I understand right, like when I actually joined, you are talking about the what do you call binomial and Bernoulli and so on. Here, is it kind of hypergeometric? Is entirely dependent, independent of all those concepts? Or is going to be the problem will be given such that we have to work on that side and then we have to come out work on the hypergeometric distribution of.
No, hypergeometric is different, right? In binomial,
Okay,
what the condition was, all my trials were independent, but in hypergeometric, all my trials are dependent on each other
dependent,
because
yeah.
we are doing it without replacement, right? In binomial, we were
Okay.
doing it with replacement, but in
Oh, yeah.
hypergeometric, we are doing it without replacement. So every trials are dependent on each other, and at each trial, my probability of success. If you see here, in each trial, so at first trial, I had 3 by 7 as the probability of success. And in the second trial, I had the probability of success 2 by 6. So that is my condition for hypergeometric. The condition it should be without replacement, and each trial, the probability of success is different. Okay?
Okay. Oh,
Hmm,
thank you.
That's the case. Okay. Then we have the last distribution, which is the Poisson distribution. Okay. So what is a Poisson distribution? Anyone?
It is
Ma'am,
binomial.
Here we have infinite number of trials.
ma'am,
Hmm?
ma'am, in hypergeometric distribution, the formula of variance, in the formula of variance, capital N is the
Number.
total number, and small n and small m are the respective means what we have to select.
Correct. So small n is like the number of items that I am selecting from capital N, and m is like the number of black balls or the number of black balls, and small n is like I'm drawing out 2 balls, so n will be 2. Okay.
Okay, ma'am.
Now we have Poisson distribution. What is a Poisson distribution? It is a distribution which gives the probability, of number of events occurring in a fixed interval of time. Okay, so that is my Poisson distribution. Okay, so let's suppose okay, so in this, the events here also, my events are independent. Okay, and we have a constant average. Okay, which is denoted by lambda. Okay, so like in the sense we have like for example, I have the number of phone calls. Okay, if I'm calculating the number of phone call in an hour. Okay, similarly the number of cars passing through a toll booth in a minute. So we are calculating the probabilities in a fixed interval of time. Then we say that it is a Poisson distribution. Okay, and the events are independent and they have a constant average which is denoted by lambda. Okay, now for this, if my x is following a Poisson distribution with parameter lambda, okay, then my PMF is represented as, how do we represent? p raised to the power minus lambda, lambda raised to the power x upon factorial x. Okay, this is the PMF of a Poisson distribution.
Sorry, what is the denominator here?
Factorial x, or you can
Okay.
just represent it as x factorial. Okay,
Oh,
sorry, yeah, I'll just. Okay, this is other representation of factorial. This is the
so
PMF.
here, the thing is that so the Poisson distribution is dependent on time, and whereas the binomial is not dependent on time.
Huh,
Is that like?
huh, you can say that. Okay, so this is a Poisson. Okay, now for
And,
Poisson as well.
this is what you have written. X is similar to Poisson in bracket lambda.
This is similar to Poisson. X is following Poisson distribution with lambda. Similarly, we can show it as X is following a binomial distribution with parameter n comma p. So what is n? N is the number of times, the number of trials, and p is the probability of success. Okay, this is how we denote the random variable. If my x is following a Poisson distribution, so it will be x follows Poisson with the parameter. So here we have a parameter lambda. Similarly, if x is following binomial, it is written as x following binomial with parameter n comma p, where n is the number of trials and p is the probability of success. Okay.
Okay, ma'am.
So okay, so for
Ma'am, I
Poisson,
didn't understand this.
sorry,
I didn't understand this.
which one?
The PMF.
This is the PMF. So my PMF of the Poisson distribution is e raised to the power minus lambda, lambda raised to the power x upon factorial x. That's it.
Ma'am, is there any reason why it's like this?
It's like uh, there is a derivation, like from the binomial only we are getting this formula. So it's a very lengthy thing. That that's like it's a very lengthy process. Whole derivation is there. So from that derivation from binomial, when we take n as infinite, then only we get the distribution, the PMF of a Poisson distribution. Okay.
Okay. Ma'am, and what is lambda?
Lambda is the parameter, or you can say the average.
Average of the random variable.
The average of the, like, if lambda is like the average of the events per interval. Okay. So what is the Poisson? We are finding out the probability of number of events that is occurring in a fixed interval of time. So the if we are calculate, so lambda is the average in that particular interval of time. Okay. So that is my lambda. Fine.
Ma'am, average of what?
Average of,
Like it's constant average. Average of what exactly?
let's suppose I have a situation like I need to calculate the number of cars passing through a toll booth. Okay, in a minute. So if I have to calculate the average of that, what will it be? It will be the average number of vehicles which is passing through that toll booth per minute. It is about coming out to be like 120 per hour, 120 per minute, something like that. So that is an average.
Okay.
Okay. Yeah.
Yes.
Is it fine? Now you got it. What is
Yes,
lambda?
ma'am. Yes, ma'am.
Yeah. So we are just
Yes.
denoting that average with a uh, random with a parameter which is lambda. Okay. In binomial we had p, right? What is p? P is probability of success. Similarly, in Poisson distribution, we are just denoting the average with a value as lambda. Okay. Is it fine? Now is it fine? And for Poisson
Yes,
distribution, my value of expectation and variance is same, which is lambda. Okay, you have to remember this. So if you need to calculate the expectation of a Poisson distribution, it will be equal to the parameter. Okay.
okay.
Is the thing clear? This was the Poisson, this was the hypergeometric, we had the binomial. So all of these things is clear. Like overall, the formulas, the conditions, when do we have the binomial, when we have a hypergeometric, and when we have the Poisson. Is it clear,
Yes, sir.
everyone? If you are
Yes.
confused or something, just let me know. Then
Ma'am,
we will proceed with it.
what is lambda here in Poisson distribution?
It's a parameter, or the parameter of a Poisson is a lambda, where lambda is the average rate.
Means average of whole data.
The average, let's suppose if I have I gave the average of not the whole data. If you are calculating the average of the per interval, like average per interval, that is a okay. If let's suppose if the number of like I gave the example, number of cars passing through a toll booth, okay, in a minute. So if I have to calculate the average of that, what will it be? It will be the average of the cars passing through that toll booth in a minute, right? So that is my lambda. Okay. Okay.
Yes, ma'am.
Can you explain random variable in context of hypergeometric distribution?
Random variable in the context of hypergeometric.
Like if we draw n balls, like out of capital N balls, we draw n balls without.
Capital X is basically the number of black balls that I'm going to draw. So in the example, if I showed you here,
Yeah.
so I have 7 balls, right? So
Yes.
if I have to calculate, this is probability of X equals to 1. That is the number of what is the probability of getting only one black ball?
How many
that
balls
is
we are drawing in total without replacement?
2.
2. Okay.
Okay.
Yeah. So one black ball is drawn, then and another black ball is drawn in second draw.
Correct.
So we can have 0 black balls or 1 black ball or 2 black balls.
We can have, yes. So we can have, so my X will take different kind of variables, different kind of values. We can have 0, we can have 1, we can have 2.
Yeah.
Okay. So for
Okay.
different of cases, we can have different types of probabilities. For each of the cases, we have different probabilities that you have to calculate. So how will you calculate? By this formula. Okay.
Okay. We have X black. These X balls are drawn in total n draws, na?
So you are taking out two balls. Okay. So I'm asking you, what is the probability of getting only one black ball? So that is my X equals to 1.
Okay. So what is the probability associated with X equal to 1?
So that is this one, 3C1, 4C1 divided by 7C2. So you have to calculate this
7.
value.
Okay, number of 3C1 into 4.
Yeah. So
One black ball. Okay. One black ball. Okay. So one black ball could occur, ma'am, black ball could occur in the first draw or it could occur in the second draw.
one second, what? So these are my conditions. So if I need to find so I'm taking out two balls. Okay. So I need to calculate, I should get only one black ball. So my condition would be what? So from the three balls, only one black ball I have to take out. Into the next ball will be automatically my white ball. Correct? So it will be 3C1 into 4C1 divided by 7C2.
If we take white balls as W1, W2, W3, W4, and black balls as B1, B2, B3.
Hmm.
So that way, like
So from the
if
three black balls, the three B1, B2, B3, I'm taking out only one ball, na?
B1 and suppose W1,
Uh,
and then
ah,
B1, then W1 and B1 can also occur, na?
no, we have the same type. Like all my balls are of same type. So black balls are of same type. My white balls are of same type. Same type. Okay. So from that balls, we are taking out only one ball. From three black balls, which are of same type, I'm taking out only one. Similarly, from the four white balls, which are of same type, I'm taking out one.
Okay.
Okay.
Yeah.
Yeah. Now is it fine?
Yes.
Okay. So
Ma'am,
can we, yes.
can you write what in capital in small in are represented?
You're not audible, but
I'm just asking if can we just write what in capital in small in are representing here?
okay. So see, we have n total balls. So according to the example, what is my n? 7 balls. Okay. From that 7 balls, I have, let's suppose my m is like, so we are talking about black balls. So m is like black balls, which is 3. And n minus m is what? I have white balls, which is 4. Okay. Now from these 7 balls, I am taking out 2 balls. Okay. So small n is the number of items that I'm taking out, the number of balls I'm drawing out without replacement. Okay. So from that n, how many of them are like the number of black balls? That is, it is 1. And n minus x would be what? 2 minus 1, which is 1 white ball. Now you got it?
Yes,
Now is it fine?
yes, ma'am.
Yes or no? I'm not able to hear you.
Yes, ma'am.
Okay, fine. So, okay. So should we go to the questions now? Maybe we will understand more. Shall we?
Yes, ma'am.
Okay. So we have the first question here.
Ma'am,
Following,
ma'am, at the end of this session, can you please tell us like a little about the activity 4? I'm having difficulty in understanding it actually.
okay, yeah, fine. Okay. So the first question is, following out the experiment, tossing an unbiased coin for 100 times and counting the number of heads, tossing a biased coin for 100 times and counting the number of heads, choosing 5 balls randomly from an urn containing 20 yellow balls and 20 red balls without replacement and counting the number of red balls. So which of these is not a binomial experiment? Just read the
C,
statement carefully. Huh?
C,
B,
C for cat.
C. Okay. What about others?
C.
Ma'am, B, right? Because it's biased coin.
Okay.
It doesn't matter whether it's a biased coin.
C.
So majority of them are saying C. And B is also the answer.
Ma'am, both B and C.
Both B and C. Okay. That's the final.
Yes,
Okay,
No,
so
ma'am, only C.
only C. Okay, now
Only
for a binomial experiment, what are the conditions? The first condition is n should be fixed, right? We should have two outcomes, which is success and failure. And for each of the trials, my probability of success should be same. Correct? These are my conditions.
yes, ma'am.
Yes or no? Okay. Now for the first thing, tossing an unbiased coin for 100 times. So here my n is fixed and counting the number of heads. Okay. So my n is fixed. So for each of the, it is unbiased. For each of the trial, I would be having fixed p,
Yes,
right? My fixed p in the sense the probability of getting a head and tail, which is 1 by 2 in each of the trial.
yes, ma'am.
Okay. So I have n fixed. I have the probability same for each of the trials. So that means this is a binomial experiment. Correct?
Yes,
Yes.
ma'am.
Now, second case, tossing a biased coin for 100 times. So this is my n. Now, if this is a biased coin, then also I will be having two outcomes, success and failure. But I won't be knowing what is my probability of success and what is the probability of failure. Maybe it is like some p will be my success, but for in each trial, I will be having the same probabilities for each trial.
No. Yes, ma'am.
Yeah. Okay. So I'm having n fixed. I have two outcomes, success and failure. And for each trial, I am having the probability same as well. So is this a binomial experiment?
Yes, ma'am.
Yes, ma'am.
Yes. Yeah. Now, third, choosing 5 balls randomly from an urn containing 20 yellow balls and 20 red balls without replacement. So here we see we have without replacement. They are not independent. So if they are not independent, this is not a binomial experiment. Got it?
Yes, ma'am.
Yes, ma'am.
First question is clear. Now you got to know how to see whether an experiment is a binomial. Now you got a rough idea. Now is it clear?
Had it been with replacement, then we can say it's binomial, is it? Like without replacement, if you replace with replacement.
If it's with replacement, okay, then we should have, so for in each trial, we should have a probability of success as well and probability of failure. So what is the probability of success? It should be there written. So see, the main thing is for binomial, the thing is your number of trials should be fixed. You should have two outcomes only, and the probability should be same for
ma'am,
each trial.
success here is actually the number of red balls. Success is red ball actually. In each trial, success will be red ball.
So if it's a red ball, so what is the probability of getting a red ball?
Then 1 by 2 in each trial.
1 by 2.
Yeah, ma'am. 20 yellow and 20 red balls. If with the replacement we are drawing the balls.
So it should be clear, right? So like it should be written in the question that drawing out a red ball is equally likely as drawing out a yellow ball. Then it will be said that the probability is 1 by 2, like that. It should be mentioned in the question. If it is not mentioned, then like it will be clearly mentioned to you. Then only you can say whether that's a binomial or not.
Ma'am, it is mentioned counting number of red balls chosen. So
Randomly from with the question. I'll just come back to that. Yeah. I'll just think about
Okay.
it and let you know. Okay. Now, second question. A company is planning on expanding its reach. It is planning to open at least 2 more branches in the city and is considering 4 different locations for it. The probability of successful opening of a branch at a location is this, and the success of branches are independent of each other. Find the probabilities that exactly 2 branches will be successful. So what is it given? The thing is, a company is planning on expanding its reach. It is planning to open at least 2 more branches in the city. Okay, that is like at least 2 more. Okay, and it's considering 4 different locations for it. So we have 4 different locations, and they're opening at least 2 more branches. Now, the probability of successful opening of a branch at a location is 0.65. So let's suppose I'm denoting X that they open branch successfully. Okay, so that is my uh, X. So of the probability that the probability of success, that is P, small p, is 0.65. That is the probability of success. And they have said that the success of branches are independent of each other. So if they are independent, that means this is a binomial case. We have a success and a failure. What is the success of opening a branch, and failure is not opening a branch? So we have 2 outcomes as well. Okay. Now, find the probability that exactly 2 branches will be successful. Okay. That means we need to find out probability of X equals to 2. Correct? Is the question clear? Or no?
Yes, ma'am, it's clear.
Yes, ma'am,
It's,
clear.
it's clear. Okay. So can you guys calculate it? What's the formula? You remember? This is my
NCX
formula.
guys.
NCX PX 1
P
minus
raised,
P whole to power n minus x.
yeah. So according to this question, just put the values and tell me the answer.
Is it 0.310?
Sorry.
Is it 0.310?
What are the values that other people are getting?
Zero point 310.
0.310. Okay, so okay. Probability of X equals to 2 will be what? Can you tell me what is my N here?
4.
4,
It will be 4. So 4, 3,
2,
2.
0.65 raised to power 2, 0.35 raised to power 2,
0.35.
35.
35 whole
0.35.
square.
Failure.
Yeah. So this some answer will be coming. So your answer should be in the range of 0.308 to 0.312. This should be your answer. Like in between this, your answer should be there. Is it coming or not?
Yes, ma'am.
Yeah. What about others? Have you guys solved it? I'm getting only 1 or 2 answers.
Yes, ma'am.
Yeah.
Yes, ma'am.
And
Now you got to know how to solve. Yeah.
sorry for that. So this range for binomial, because you said binomial distribution is the same across all. So for all the questions of binomial distribution, this will be the range.
No, 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 no. Like this is from the activity question that I have taken. So I've not calculated the correct value. So I'm just telling you that answer should be in between in this range. If your answer is coming in this range, then it's fine. Like that.
Oh, so it does not mean that binomial distribution will have this value. It may differ from each problem.
Huh.
Okay. Because I thought it's a kind of a general value that it has to be narrowed down.
Okay. Is the question clear?
Yeah.
Now you got it, how to solve a question like binomial thing. You got to know what it is a binomial, then you put the probabilities and all, right? Now you got it?
Yes,
Yes,
Is
ma'am.
it? Oh, fine. Now, suppose five pair dice are thrown independently. X represents the number of dice where the multiple of 4 appears. Find the probability that at least 3 of the dice show a multiple of 4. Okay, so what is my n here? I have 5 pair
5.
dice. Yeah, so this is 5. Now, X is representing the number of dice where the multiple of 4 appears. Okay, it is the number of dice. Okay, now you need to calculate the probability that at least 3 of the dice show a multiple of 4. That means I have to find out probability of X
Is equal to 3.
Greater than equal to 3.
greater than equal to 3. You need to find out this thing.
Please.
Okay, that means you need to calculate probability of X equals to 3 plus probability of X equals to 4 plus probability of X equals to 5. Correct? Yes or no?
Yes, ma'am.
Oh, yes.
Okay. So here, what is my probability of success?
Ma'am, can you repeat the question?
What is the probability of success?
1/6.
It will be 1 by 6. Okay. How is it 1 by 6?
Multiple of 4 is only 4, so 1
Yeah.
up to 1, 2, 3, 4, 5, 6.
Yeah, correct. So the thing is, the success is the getting the multiple of 4s, right? So in a dice, I have 6 faces, right? 1, 2, 3, 4, 5, and 6. So in this, which like how many numbers are the multiple of 4? Only 4 is there, correct? So the probability of getting 4, that is the probability of getting success is what? 1 by 6. Got it? Is this thing clear?
Yes, ma'am.
Yeah. So calculate and tell me the answer.
Ma'am, is it 2?
No. You have to put all the values here, right? Are you guys able to solve it? Like,
Is
I
it
think,
0.025?
yes, it's 0.035. So now, what will be my probability of x equals to x? It is basically what? 5cx p raised to the which is 0.6 raised to the power x 0. Sorry, 1 by 6. It will be 1 by 6 raised to the power x, then 5 by 6 raised to the power n minus x. So probability of x equals to 3 will be what? 5c3, 1 by 6 raised to the power 3, 5 by 6 raised to the power 2. Similarly, probability of x equals to 4 will be 5c4, 1 by 6 raised to the power 4, 5 by 6 raised to the power 1. Then probability of x equals to 5 will be 5c5, 1 by 6 raised to the power 5, and 5 by 6 raised to the power 0. Then you have to add all these values. Fine. Have you guys solved this question? Yes or no?
Yes, ma'am, got it.
Yeah. Okay. So shall I move forward now with the next question?
Yeah, ma'am.
Okay. Now, an archery trainer wants to test the archery skills of a newly joined students, which include some prodigies. We have skilled and we have talented. The trainer puts up a circular board of radius 20 meters. If the student shoots an arrow in the region of radius 5 meters, then the trial is considered as a success. The student undergoes 3 trials and need to get at least 2 success out of the 3 trials to pass the test. Prodigy is a student who has very good archery skills when compared to the normal students. What is the probability that a normal student will pass the test? So if a normal student has to pass a test, what is the probability that we have to calculate?
Probability that the students shoots an arrow within region of radius 3 meter.
No, will pass the test. Who will pass the test?
Will pass.
If the probability that he will that he get at least 2 success out of the 3 trials, right? That is probability of x is greater than 2, correct?
Yes, ma'am.
Yes or no?
Yes.
Yeah. So
Yes.
probability that x is greater than equal to 2. Now here, what is my n?
3.
N is 3. Okay. Now, what is my probability p?
9 by 25.
9 by 25. How it is 9 by 25?
Because he needs to hit in the region of radius 3 and total region that is
Radius of
3
5, na?
radius of 5 and success is when he hits within radius of 3.
No,
No,
it's 1 by 6.
1 by 6.
It will be 2 by 3 into 5 by 20. So 2 by 3 into 1 by 4, which is 1 by 6.
see, it's simple. So we have like we have a circular board which is of radius 20. Okay, and the success is what? If he like shoots the arrow in the radius of 5 meter. Correct? This is my area. So I need to calculate the probability of success. What is probability of success? Probability of success is the success
1 by
area
6.
divided by the total area. Correct? Yeah. So what is my area for the success? It is pi r square, which is pi into 5 square. Correct?
Okay, yeah.
Divided by pi into my
20
total
square.
area, which is 20 square, which is 25 by 400.
Right.
Correct?
Yes.
So this is my probability of success.
by 8.
So this will be what? 5 by 80.
And 1 by 16.
Okay. So this is my probability of success. Now we have the probability of success. We have n. Now you have to calculate the probability that x is greater than 2, which is probability of x equals to 2 plus probability of x equals to 3. Okay. Now you calculate and tell me the answer. You got the question, everyone?
Yes, ma'am.
Yes,
Sure?
ma'am.
Okay. Tell me the answer. Like after solving, tell me the answer.
Tanishba.
Mhm. Yes.
And is it 0.01123?
0 point
0.1123?
112. 112. Yes, yes. What about others? Have you guys solved it?
Ma'am, 0.0112.
0.0112. Yes. Is the question clear? You are able to solve the question, right?
Yes, ma'am.
Okay. So you got the concept clear. What is a binomial? How to do the questions? How to calculate the probability of success and everything, right? Okay. Shall we proceed to the next question, or should I wait for more? Uh, is anyone doing the question?
Sorry, I didn't get that. Could you please? I didn't
What
get
was the
it.
answer?
Maybe I'm wrong somewhere.
Sorry.
And
What
what
was
was the answer for that question?
0.0112?
I didn't get that. So probability of 2 will be 1 by 16 into 1 by 16 into 15 by 16, right?
Probability of
Yes, ma'am, that's correct.
Probability of 2 successes will be 1 by 16 into 1 by 16 into 15 by 16, right? And probability of 3 successes will
3.
be 1 by 16 cube.
This will be the thing. Okay. And probability of
See,
x equals to 3 will be 3c3 1 by 16 raised to the power 3, 5 by 15 by 16 raised to the power 0. Okay.
C2. Yeah, I missed the 3C2 part.
Huh.
Okay.
Okay. Now is it fine? Are you getting the answer?
Yeah, ma'am.
So shall I proceed to the next question or should I wait?
Thank you.
Okay. Now, the next question. If the variance and expectation of a getting number of tails in tossing a biased coin is 1.05 and 3.5, what is the probability of getting 3 tails? Okay. So what are the values that we have been given? We have been given expectation, which is 3.5, and we have the variance, which is 1.05. Correct? Yes or no? We have been given
Yes,
this
ma'am.
value. Okay. So
Yes,
for a
ma'am.
binomial, what is the formula of expectation?
NP
NP. And the variance is
P times
N
1.
into P into 1 minus P.
N in, this is the thing. Okay. Now, what is the question they have been asking? They are asking what is the probability of getting 3 tails? That means the probability x equals to 3. Correct? So for this, I need the value of n, I need the value of p, right? Yes or no?
Yes, ma'am. Two
Okay.
equations, two
Yeah.
variables,
So we
solution.
have 2 equations. You need to solve this equation and get the value of n and get the value of p. So can you guys solve this question and let me know what is the value of n and p?
Yes.
Sorry?
Yes, ma'am.
Yeah. So solve it and let me know the answer.
Ma'am, n equals to 5 and p equals to 0.7.
N is equals to 5 and p equals to 0.7. What about others? Are you getting that answer?
Yes, ma'am.
Yes?
Yes,
Yes, ma'am.
Okay. Now you have the value of n, you have the value of p. So now can you calculate probability of x equals to 3, which is 5c
3,
3
0.7, this power 3.
3 and 0.2 raised to the power 2. Correct? Now
Yes,
solve this and tell me the answer.
And is it 0.3087?
Yes. What about others?
Yes, ma'am. Same.
same as the ma'am.
Same, 0.3087. Okay. Okay. Shall we proceed to the next question then? Is the question clear?
Yes,
Ma'am,
ma'am.
n is 5, how n is 5?
Sorry?
Ma'am, how n is 5?
How n is 5? So first, like, have you solved this equation? It's coming out to be 1.65, correct? If you see here, so my value of NP is what? 3.5, right? So I can substitute NP as 3.5. So this will be 3.5 into 1 minus P is equal to 1.05, right? So now 1 minus P is what? 1.05 divided by 3.5. Now, from here, my P is what? 1 minus 1.05 divided by 3.5. If you calculate this value, what is the value that you are getting? What is the value I'm getting?
2.4.
This is 1 minus 0.3. 1 minus 0.3 is 0.7. So my value of P is 0.7. Now put this value of P, N, P equals to 3.5. Now value N into 0.7 equals to 3.5. So what is N? N is 3.5 divided by 0.7. So if you calculate this will be 5. Is it fine? Is it clear? Yes or no? Shall I proceed further?
Yes.
Yes, ma'am.
Yes? Okay. Now, Ritika wants to test whether the coin she has a pair or not. To test this, she conducted an experiment of tossing the coin 4 times. Binomial random variable x is defined as the total number of heads after 4 tosses. The PMF is given. What is the probability of getting a head? Can you tell me what we need to calculate? Anyone? See, what we have been given an experiment of tossing a coin 4 times. So we have n. So what is my n? N is 4. Now they are saying that my x is a binomial random variable, which is defined as the total number of heads after 4 tosses. Okay. So my probability of success is what? Getting head. Correct? Now we have been given the PMF. So my x is taking value 0, 1, 2, 3, 4. This is the number of heads that I'm getting in 4 tosses. Right? Now, I have to calculate the probability of getting ahead. What do you mean by probability of getting ahead? In the sense, I need to calculate probability of success. Is it clear? Is the question clear?
Yes, yes, ma'am.
Yes. Everyone?
Yes, ma'am.
Okay. So, can you calculate the value of P? You have all the probabilities. So how will you calculate? From probability of x equals to 0, you have 0.1296. So what is probability of x equals to 0? It is NCx p raised to the power x 1 minus p raised to the power n minus x, right? So in place of x, I have 0 value, correct?
Yes, ma'am.
And in place of n, I have what? 4. So it will be 4c0 p raised to the power 0 and 1 minus p raised to the power 4, which is 0.1296. Now, what is 4c0? It is 1. So this will be 1 minus p raised to the power 4 equals to 0.1296. Now you have to take you have to solve it like what is 0.1296, the square of this. So you can just solve it like 1 minus p raised to the power square. If you square out this, it will be 0.36. Then again, if you square this square root, you will be taking 0.6. Then what is p? It will be 0.4. Is it fine? Similarly, you can take different values. Probability of x equals to 1 or 2, 3, 4, anything. Okay? So it's better you can take x equals to 0 and x equals to 4. Why? Because if we take probability of x equals to 4, okay, this is what? 4c4 p raised to the power 4 and 1 minus p raised to the power 4. Sorry, 0. Okay. So now if you calculate 4c4 is 1, p raised to the power 4 into 1 minus p raised to the power is also 1. So I will be having only one variable, which is p raised to the power 4. So it makes the calculation more easier. Is it fine?
Yes.
Everyone?
Yes, ma'am.
Sure? Can I move forward?
Yes, ma'am. Yes, ma'am.
Okay. Or yeah, you can do that. Or you can do it like okay, or also you can calculate it like mm, you know the formula of expectation, right? Which is summation of x into px. So from this formula, can you calculate the expectation here? You will have some value, correct?
Yes.
You will calculate this value. And according to binomial, what is the formula of expectation? It is n into p? Yes or no?
Yes, sir.
Yeah. So you have the value of n. So the value of p would be what? The sum of all the probabilities, the product of the values of the probabilities divided by 4. So if you calculate this value also, you will get p as 0.4. Fine. So there are different ways you can solve this question. Is it fine?
Yes, ma'am.
Yes, ma'am.
Everyone? Is it confusing or something else? Is the question fine? Shall we move forward now?
Yes, ma'am.
Okay. Now, okay, in binomial. Okay, we have if the variance of a binomial random variable for n equals to 8 is 1.92, what are the possible values of p? So what is the formula of, sorry,
0.24
0.24 for what?
p.
How did you calculate it?
Ma'am, np equals to 1.92
np equals to 1.92.
and n equals to 8, so I've calculated from there.
I got it, but now only I started this question and you got the answer. Okay, can you tell me the formula of variance of binomial random variable?
Ma'am, variance is np and standard deviation is npq.
I'm talking about
No, ma'am.
variance.
NP into 1 minus P,
NP into
probability
1
of
minus
success
p.
minus into
Yeah.
failure.
So this is my NP into Q is basically what? 1.92. And I have the value of n as 8. Now they are talking about what are the possible values of P. You need to calculate the value of P. So this is NP 1 minus P equals to 1.92. That is 8P 1 minus P raised equals to 1.92. Now, how are you going to calculate this? P 1 minus P equals to 1.92 divided by 8. You will be having some formal value. Then this will be P
0.24.
minus P square equals to, what is this value?
0.24.
0.24. So this is 0. This is 0.24. Now this is P minus P square minus 0.24. Or you can say it as P square minus P plus 0.24 equals to 0. Now if you solve this, you will be getting values of P. You will be having two values of P. Solve it and let me know.
Ma'am, 0.6 and 0.4.
0.6 and 0.4. What about others?
0.6 and
0.2 and 0.4. Okay. Is the question clear? Shall we move forward now?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, suppose we draw 8 cards from a pack of 52 cards without replacement. Then what is the probability of getting less than 3 spades? Now, what is this experiment?
Hypergeometry.
Why it is an hypergeometric?
Ma'am, without replacement, so it is dependent on a number of items.
Huh. So can you guys tell me what we have to calculate? So what is my x here?
0, 1, 2, and 3.
X. Okay, no. Can you tell me what x represents here?
Ma'am, number of spades.
Number of spade
Yeah,
cards.
we have the number of spade cards. Okay. Now, we have to calculate probability of x less than 3. That means we have to calculate x is less than 3. Yes.
0, 1.
Yes.
So this will be probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Correct?
Yes.
Yeah. Okay. Now, can you tell me what is probability of x equals to 0? So just make it this thing. We have 52 cards. That means my n is 52. From this n, how many spades are there? M
13.
is 13. So my n minus n will be what?
13.
39.
39. Okay. Now, here, what is my small n? From
8.
52, it will be 8.
8.
Okay. Yeah. So now we have to calculate probability of x equals to 0. Okay. Can you tell me what is probability of x equals to x? Can you tell me the formula? It is
Yes, ma'am.
MCX.
MCX, n minus MC, n minus MC, n minus x upon NCN.
NCN. So what is probability of x equals to 0? It will be 8.
8C0.
8C0. Hey, what is n? 13, right? 13C0, 39 C8 divided by 52 C8, correct?
Yes, ma'am.
Yes.
This is the this is a simple condition. So I need probability of x equals to 0. That is the number of spade cards. So I have 0 spade cards. So what is the probability? So from 13, I will have 0 spade card, and from the 39, I will be taking out 8 cards divided by the total probability 52 C8. Similarly, what is probability of x equals to 1? It will be from the 13 spade cards, I will be taking out 1 card, and the remaining 7 cards will be taken out from the remaining 39 cards, and the total probability is 52 C8. Fine. Similarly, what is probability of x equals to 3? 2. It will be
13C2, 39C6, 52C.
13 C2, 39 C6 divided by 52 C2. Correct?
Ma'am, C8.
Sorry. C8.
52 C8.
Is this thing clear?
Yes,
Now
ma'am.
it's a very big thing. You can calculate on. Is the question clear? Now you got it, how to solve the hypergeometric. Is it fine?
Yes, ma'am.
Okay. Let's proceed to the next question then. In a box, there are 10 chocolates, of which 6 are milk chocolates and 4 are dark chocolates. 2 chocolates are drawn at random. What is the expected number of dark chocolates drawn? So what we need to calculate the expected number. Okay, expectation. So now, what is the formula of expectation of a? Okay, so is this a hypergeometric or a binomial?
Hypergeometric.
This is hypergeometric. So for a hypergeometric, what is the value of expectation?
N m by m.
Nm upon m. So now, can you tell me what is n here?
Number of trials.
2.
It is 2. What is n here?
Ma'am, 4.
It will be 4 because we are talking about dark chocolates, right? So my m is 4. Now, what is capital N?
Total chocolates
10.
10.
It will be 10, right? So now, what is my expectation? It will be 2 into 4 divided by 10, correct?
Yes, ma'am.
Which will be 0.8. Is it clear?
Yes, ma'am.
Is hypergeometric clear to everyone? Yes or no?
Yes, ma'am. Yes,
Okay.
ma'am.
Let's proceed to the next question. A car hire firm has 2 cars, which it hires out day by day. The number of demands for a car on each day is distributed as a Poisson distribution. So it is already given. This is a Poisson distribution with a mean 1.5. So with a mean 1.5, that means this is the value of what?
Lambda.
This is lambda. Now calculate the proportion of days on which neither car is used. That means I need to calculate probability x equals to x equals to
0.
0.
yeah, x equals to 0. That means neither of the car, not the 2 of the cars have not been used. Probability of x equals to 0. Now, for a Poisson distribution, what is the PMF?
To the
Uh,
power
E raised to
minus
power
alpha
minus
into
lambda.
10 to the power x by x factorial.
Lambda raised to power x by x factorial.
X factorial. So here we need to calculate probability of x equals to 0, which is e raised to the power. What is value of lambda?
1.5.
1.5 into 1.5 raised to the power
0.
0 divided by factorial 0. So if you calculate this, you will be getting some value. Okay?
Yes, ma'am.
Is the question clear for the Poisson? Any doubts?
Ma'am, we have to take the absolute value.
We have to take the absolute value of what?
Uh, 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 can we not take e to the power minus 1.5, or we have to solve overall?
We have to solve this, na? So for this, this is 1, so this will be e raised to the power minus 1.5. So you have to calculate this value. What is e raised to the power minus 1.5?
1 by e to power 1.5. So, ma'am, what should we take the value of e? It's varying.
No,
So,
no,
is it
like
given
from
in the
the,
question?
you have to calculate it, right? So it will be e raised to the power minus 1.5. So this is 0.223. So this is coming out to be 0.223. This is from the calculator, you can calculate the exponential of the exponential value, right? E raised to the power minus 1.5. You calculate this, look, this. Try to calculate it. Are you getting
Ma'am,
that
what
value?
value of e has you taken? Value of e?
Value of E,
Yes, ma'am. Uh, 2 point.
2.71 or 72 something. But why are you taking the value of E? You just, like in the calculator, you can already calculate the exponential value, right?
Yeah, okay, ma'am.
Yeah, you just calculate it like that. Okay?
Yeah, ma'am, got
So now is it fine? Is the question clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now let's proceed to the Last question. The number of person arriving per hour in an insurance company for the insurance of their car follows a Poisson with a parameter 6. So what do you mean if the parameter is 6? That means this value is what?
Lambda.
This is lambda. Okay. Now find the probability that exactly 7 people will arrive during any 90-minute period. Okay. Now read the question carefully. Okay. And tell me what we need to calculate.
We have to multiply 6 into 1.5, which is like 90 minutes, into hours as like lambda value.
Huh. Yeah. So basically what it is given, it is given that for one, okay, so it's given that my parameter, this is 6, that means the average value. So this average value is what? 6 per hour, correct? Now what I have to calculate? I have to calculate for 90-minute period. That means I need to calculate for 1.5 hour, right? So for that for 1 hour, I have the average as 6. So what is the value for 1.5? It will be 6 into 1.5. Yes or no?
9.
Yes.
Yeah, that will be my 9. So now this is my lambda. This is my new lambda. This lambda 6 parameter was for per hour. Now I need to calculate lambda dash for the new hour, which is 1.5 hour. Now I need to calculate probability of x equals to
7.
7, which is e raised to the power
Minus 1.5. Minus 9.
-9.
1.9 raised to power 7 divided by 7 factorial.
Divided by 7 factor. Is the question clear? How to solve it?
Yes, ma'am.
Yes.
Sure?
Yes.
One more question is there. Okay. Is the question clear?
Yes, ma'am.
Yes, ma'am.
Yeah? Okay. Now, last question. Yeah, this is the last question. Suppose that the random variable x follows a Poisson distribution such that the value of expectation of x square is 6. What is the value of expectation of x? Okay,
Lambda.
so for a Poisson, what is the value of expectation of x? It is lambda,
Yes, ma'am.
right? Yeah. And you have the value of expectation of x square as 6. Now, what is the value of variance of x? It is also lambda?
Yes, ma'am.
Yeah. Okay. Now, do you know the equation of variance of x? How do you
Yes,
calculate
ma'am.
it? Which
Ma'am.
is
Yes, ma'am.
expectation of
Ax
x
square
minus
minus
expectation of
whole
x
square.
whole square. Correct? Now, variance of x is lambda. Expectation of x square is 6 minus lambda square. Correct?
Yes, ma'am.
Now, I need the value of lambda. So I put it here. So lambda square plus lambda minus 6 equals to 0.
Yes, ma'am.
Now, you solve it and tell me the answer of lambda. What are the values that you are getting?
3.
Minus 2.
Minus 3 into
Minus 3,
And 2.
minus 3 and 2. Okay. So now I have the two values of lambda, which is minus 3 and 2. Now, which is the correct value of lambda? What will I be taking?
It will be 2.
It will be 2 because we won't be
2.
taking the negative values. We only be taking the positive values. Okay. So for lambda, my value of lambda will be equals to 2. Is it fine?
Yes, ma'am.
yes.
In one question, lambda is minus 1.5. So lambda is negative can be possible.
No, no, lambda can't be negative. Okay. Is it fine?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes.
Ma'am, can you please share this PDF in the chat?
In the chat, I will be uploading it.
Ma'am, from where we can access it?
No, I will be uploading it in the supplementary content. So you can access it from here. There.
Okay.
Okay. So always remember that. So always remember that my lambda is always positive. What is lambda? Lambda is basically my average rate, right? So can my average rate be negative?
No.
No, right?
No, ma'am.
So that's why. So we always take lambda as a positive, right? So I guess like is week 11 clear? I know I had a lot of there was a lot of questions, but yeah, you got the point, right?
Excuse me. Oh, ma'am, lambda always also denoted as parameter. So what parameters should it define? Yeah,
Sorry, what once again?
like number of customers visited after every 10 minutes. So
Hmm.
what parameters should lambda define here?
Lambda is what? The average rate, correct? So you need to, so lambda, you have to calculate the average number of people who are coming to the store in 10 minutes, like that. So that will be my lambda.
No, ma'am. It's
Hmm.
also called as parameter. So what's parameter is should be defined.
So the parameter, so for Poisha, the parameter lambda, so that lambda is denoting the average rate. Okay.
Uh,
Yeah. So average rate per interval. So if according to your example, your lambda will be what? The average number of person who are coming into your shop in 10 minutes.
every 10 minutes. Yes, ma'am.
Ha, ha. Okay.
Oh, yes.
Yeah. Lambda, why lambda is my parameter? Because in the formula, if you see, it is e raised to the power minus lambda raised to the power x upon factorial x. So in that particular, my lambda should be there so that I can calculate the probabilities, correct? Similarly, in binomial, we have two parameters, n and p. So if you see in the formula, it is ncx p raised to the power x, 1 minus p raised to the power n minus x. So if we have the formula of n, values of n and p, then we can calculate the values of x, correct?
Yes.
Yeah, so that's why we have the parameters. For binomial, we have n comma p, and for Poisson, we have lambda as the parameter. Okay?
Couch E is constant.
E is a constant. Yeah.
Yeah, okay.
Hmm. Okay, so tell me if week 11 is clear to you or not.
I'm clear.
Sure. Hypergeometric binomial Poisson, is it clear?
Ma'am,
Or
I have a
sorry?
uh, is week 12 also conducted in this week?
Week 12. Yeah.
Yes, ma'am. Both have same deadline.
Week 12 has same deadline.
I guess it's also 20 August.
Ma'am, week 12 is revision.
Week 12.
Week
I
12
guess
classes.
there are some
So,
new concepts.
yeah, it's
Only
about
week 12 CT is revision, rest are not.
No, CT and Maths is division. English and stats are having concepts.
Okay.
Just a second. Week.
Yeah, the week 12 has all the continuous random variable everything.
Yes, ma'am.
Okay. Um, okay. Okay then. So yeah, week 12 will be also be conducted. We will just let you know when the session will be held. Okay.
Yes,
Yeah. Thank you for the information. Yeah.
Ma'am, can you please
In
explain the extra activity 4?
Extra activity 4.
Yes, ma'am. It's not clear.
It's a
Ma'am,
bit complicated.
excuse me,
Uh,
ma'am.
yes.
Ma'am, actually, I have not done first three activities. So how can I do activity four? Because I missed the three activities, first three activities actually.
How to do it in the sense, like you have to read the
And the
question
first,
and
no, first three activities I have not done. I have missed actually.
okay.
So how can I, like, can I do activity four?
The best. So the extra activity is basically your bonus, right? So you can do the extra activity 4, but I guess it will affect your marks only.
Okay.
Yeah. So what is extra activity? Typical distribution. Collect the data set and try to approximate a variable. The data set to the distribution of the sample information. It's already there. Like an example is already given for the discrete case, right? So in the so
It
like
still looks a
you
little
have a sample.
complicated.
Sorry,
It still looks a little complicated.
it's not there. What?
I'm saying it still looks a little complicated.
It's complicated. Okay, so if I see here we have. So you just have to take a data set. From that data set, you have to calculate some probabilities, right? So you have to define x, then you have to calculate, so like we did in binomial and all, right? You can do binomial, you can do exponential, or you can do Poisson. So with that data that you have collected, you have to calculate, like you have to fit a distribution in that, okay? Uh, a binomial or Poisson or hypergeometric. You have to fit a distribution in that. Then you have to calculate the probability. So in the document, if you see, I have like they have the data of an IPL, okay, and the X they have defined as the number of times four occur in the first 36 deliveries. Okay, so that is my X. So with they have defined X, they have the data and all. Then they have calculated the probability of X, which is 0, 1, and 2, like the number of times 4 has occurred. Okay. So on that basis, then they have calculated probability P of success and everything. So you have to show it in that way. Okay. So you have to collect the data. You have to define X. So that data, it can be a binomial distribution. It can be an exponential, or it can be sorry, not exponential. It can be a hypergeometric. It can be a Poisson. So you have to fit the that distribution in that. Then you have to calculate the probabilities for each of the cases, for each of the x values. Okay, is it fine?
Can we do that with the old data set which we have chosen? Activity 1 and
You can use, I guess, you can use the previous data set as well.
Ma'am, do peer reviews in the extra activity needed before the last date of submission?
The peer reviews can only be done after the submission of the activity.
Okay, ma'am, but I have submitted the first and second activity, but my marks shown is 0.
What? Have you done any peer review?
Yes,
You have done peer review, like at least four reviews need to be done, 4 or 5.
I think it's five. No, then. It's three, I guess.
It's okay. It's have you done at least 3 peer reviews?
yes, I
It's
have
five,
done
it's
3.
five.
I have done 3.
You have done 3. Just a second. Let me check. I think it's 5.
Yeah,
It
it's
should
five.
be
And if you
5.
need, we can do more
Yeah,
than
ma'am,
5.
it's fine.
It's 5. It's not 3 or something. It's 5. So you have to do at least 5. So if you have
Okay,
done 5, then only the marks will be given. Otherwise, it will be 0 only.
okay, ma'am.
Yeah.
Also like the peer reviews, as in our activities will be like reviewed by the instructors as well, right?
Yeah. So after we get all the data and all, we will be reviewing all the marks. If any of the marks have been given, like there is any discrepancy in that, we will just look at it. Okay.
Because like for activity 3, I got a few peer reviews, and like for one of them, it's like I have done everything right. Like, we have choices as well. All of them is right. Then the comments is like it's just full stop. So I think because it's only full stop, it's just full stop, no other comments. So because of that, like I think I got 10 out of 100 or something. So that's why I'm like, um, that's why I asked.
Like you have a doubt, like how can you get 100 out of 100 like that?
Yeah, because no, I got 10 out of 100.
9 out
I
of
did like 10 out of 100.
once again, what?
Got 10 out of 100.
N out of 100?
Yeah.
N out of 100?
Yes, yes.
What is N?
10, the number 10.
Can you type
Nine.
it?
I am just hearing N.
Yeah, I'm also hearing N.
Ma'am,
What is
the number
N?
10, like 9, 10, 11.
Yeah,
N.
so what is N? What is N?
Just type it in the everyone chat.
Ma'am,
What is
it's
N?
not
N is 10. Okay, you
the
have got 10.
number 10. Yes, yes.
10.
Yeah, so tell me now.
We are
10
only
is
hearing
10.
the N part.
Okay.
Yeah, it's 10. Yeah, okay.
It's
Yeah.
10.
So,
Yeah.
Okay,
so
so
like,
you got 10 out of 100. So,
yeah.
okay.
So,
So, okay,
like my
just
peer
don't.
reviews are like really full stop. So I think because of that, like, and like my other 2 reviews as well is kind of similar. That's why I
Okay.
asked you if the,
Just
artwork
don't.
will be assessed by
Don't
the
worry about
instructor.
that. We will be looking into everyone's marks. If there is any discrepancy or something, we will check. Okay?
Okay. Thank
Ma'am,
you.
I have a similar complaint. Like I said to some other instructor also that I got 89 out of 100 in my extra activity 2. But everything was done perfectly. Even I got 2 peer reviews, 100 out of 100 and
Okay.
260 out of 100. But like I still didn't get 100. And they
Yeah, I
said that
had the
it can't be
same
changed
situation.
now.
Man, same problem with me also.
Okay,
Same,
so
ma'am. Activity 3.
okay, so
I honestly think this peer review thing, even if it's there, it shouldn't be used for evaluation.
Yeah.
Like it's no
Yes.
problem if it exists, but the people who are grading us, I don't know who are grading us, they are using the peer reviews for the evaluation also.
see if there are any like marks which is like you have got 0, then you have got all the like we check all of that. So don't worry about it. Okay. So we check all of that. If you have any like if we are saying that only one comment is wrong and all the other comments are good, so we check that marks. So just don't worry about it. Okay. The marks that you are getting on the portal is not the final marks. After like reviewing it and everything, then only we push the scores. Then you get the final scores. Okay.
So, ma'am, it will get changed.
Yeah, it will be changed. You're talking about extra activity fee, correct?
Yes,
Yeah.
not
So
Yes,
three.
yes.
I'm talking about two actually.
2.
Yeah.
Yes, ma'am, in extra activity 2, I
Yes,
got
ma'am.
Extra activity three is to
I had
definitely
got
a
two
problem because the only two options were
because,
visible.
yeah, it was a technical issue there.
for
But in case
extra
of extra
activity,
activity two, everyone has got less marks.
yeah. Okay. So extra activity. So, see, the thing is after when we have all the values of extra activity and everything, we take the average or we take some percent of that extra activity and we calculate the we give you the bonus and everything. Okay.
But ma'am, like, why
Just
do we
can you
get
just wait? Just can you just hold for a second?
okay?
Yeah. Sorry. What?
Ma'am, so what will happen to our extra activity two marks? Will we get an increment or will it stay the same?
Um, that is like the final marks only for the extra activity too. So just I'm saying like we will be taking all the average, or in the sense we will be taking some percent of that extra activity and we will be adding that as a bonus to your total score. Okay.
But the extra activity should be fairly given, right?
Yeah, we will just see to it. We will just talk with the team and all. Let's see what will happen.
But
Okay.
so please tell them to review the extra activity two as well as extra activity three. Like uh, we are told that extra activity three will be reviewed,
Uh,
but if they can review extra activity two as well, then that would be good.
okay. Let's
Because like I think it's better if like all our activities are like reviewed by the instructors as well. Because sometimes as students, I know there's like a lot of students, and like it would be like a burden for the instructors to review each and every student. But like I think sometimes the reviews which we give, I think will affect our marks uh, like unnecessarily or something.
Or
That's
maybe
yeah.
we can have a appeal button where we can appeal that everything is correct. That's what we have got less.
Ma'am, does this marks affect much?
It's a bonus thing, right? So if you get a good marks from the extra activity, it will be added in your final score, right?
But there are two instructions in the document. One talks about the 2 marks bonus, where they talk about we need to have an average in the mock test to get the bonus of 2 marks. And in
Mhm.
stat, again, when we go down to stat, there is a bonus mark breakage is at 3.575 plus 1.25. So what is that? Is it two different types of bonus, or for stats one we have separate process bonus thing is entirely different approach?
In the grading document, in the
Yeah, in
activity,
the
right?
yeah. The BS document, they say for on the top there is after the introduction they talk about the bonus marks, and further the two marks of bonus they say that everyone has to complete that mock test before the deadline and so on. Then only and there is an average of 40 plus also for that. And when we scroll down to start, then you have your own instruction of a split of 3.75 plus 1.25 for the extra activity based approach. So
Hmm.
how is it how it's working? It's for the general we have two and another five, or it's total in five? How is it working?
Yeah, it's total. We have um for the extra activity, you have a total of 5 bonus marks. Okay.
Okay.
Yeah.
Okay.
So like if you have completed 75% of the activities like that, you will get 3.75 marks, or 50 to 75%, 2.5 marks, like that. And from our instructor side and for the faculty, you will get 1.25 marks as the bonus on the basis of the quality of your activity.
Okay.
Okay.
So that the general 2 marks bonus is not applicable for stat then. Okay. Thank you.
Yeah. So if you guys have issues with the peer review, and I think like everybody is having that issue. I guess everybody is doing the peer reviews genuinely or in a legit way, right? So like you guys have to think you are doing the review for the other students. So see, this is just let's suppose this is just a practice to know how to like uh, like this is also a way to judge, or in the sense like you can learn how to give how to check the work of others, how to give marks. You will also know what are the wrong things they have done and everything. So that's a good practice, I guess. So if you genuinely like, it's upon you, it's upon the students to do it genuinely and in a legit way, right? And if there is, we already told you, if we see any discrepancy and everything, we will be doing it. We will be changing the marks if we see whether it's needed or not. Okay. So,
But I have faced a couple of times. I have faced last week also. I faced this week also. I had a thing that there was a submission. Of course, when I started peer review, it's giving that link. But when I saw that, when I followed the link, I don't see that activity itself in that page. I don't know how the particular student has submitted that. Rather, it says 3,
yeah,
but
so
there is nothing there in the
what all
data.
things that you're saying, if you're not seeing the link or something, then just according to that only you give the mark.
No, what I mean
That's
to
it.
say is that if they don't have anything, per se, that I came across one situation where nothing was there. They haven't worked for the third activity 3, if I'm right, extra activity 3, but still they have submitted the link for that. That is quite, I mean, one thing is it is being considered as a submission. Second, that is also being passed on to the other student for review, thinking that this is a genuine submission. But only to find when we try to see that there is no extra activity 3 at all in that page.
So just give marks according to that. If they have not submitted, that's it. You just give the marks. Then go to the next peer review. Like that. Yeah,
I've had a worse experience.
you had a worse experience. Okay.
Yeah, like I got a submission where like it's written that if you don't give me 100 marks, then then I will curse you. It's written like that.
Okay.
Yeah, that was funny.
Okay. So we have different kinds of people here. So yeah, it's fine. So according to that, just give marks and that's it. End it. Yeah.
And
Hmm.
what's the syllabus of quiz 3?
Sorry.
What's the syllabus for quiz 3?
What?
The end.
I'm just asking, what is the syllabus for quiz 3?
Quiz 3. There is no quiz. It's end term. So it's from week 1 to 12.
Yeah, in week 12, there is an additional content. Is it included in the syllabus?
What is it? What is it?
Additional content.
No, 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 no. That's not included.
Then the normal distribution, the standard normal distribution, and so on, these are excluding the syllabus.
No, week 12, like you have to like uniform, standard, normal, exponential, you have to learn it. Where is the additional content? Additional, that you have to just skip the additional content. That's it.
That's then it's not included in the history
That it
syllabus.
will not come in the exam.
Okay.
Oh, thank you. I have to leave now. I'm sorry for that. I will take leave.
Yeah, yeah.
Thank you.
Everybody has to leave. Okay, guys. Okay, good night, everyone. Bye.
Good night, ma'am. Thank you.
Yeah, good night.
Good night, ma'am. Thank you.
Good night. Good
Ma'am,
night.
thank you.
Thank you, everyone.